When it comes to digging tunnels, it seems no amount of soil, rock, clay, or mud can stand in our way. Every new tunneling obstacle pushes digging technology. In 400 BC, in the region of Cappadocia in central Turkey, workers used pickaxes to carve away at the volcanic rock, creating a network of underground caves. When foreign invaders attacked, up to 20,000 people would hide there. One of the true marvels of tunneling engineering happened in 1845, while building the first underwater tunnel that connected docks on both sides of London's Thames River. Burrowing through the soft clay and sand seemed impossible. It didn't hold like hard rock. Then engineer Brunel solved that problem. He invented the tunnel shield, a moving three-tiered scaffolding system. It allowed workers to carve out the soft clay and sand, while quickly lining the tunneled area with bricks. This tunnel is still in use today as part of the London Underground's East Line. 150 years later, today's high-tech tools can tunnel through 250 meters of earth in 3 days. That's the length of 8 freight train cars. High in the Swiss Alps, it usually takes 4 hours for a train to twist and turn through the mountains from Zurich to Milan. To cut the trip in half, engineers decided to build a straight tunnel between the two cities. For passenger trains to hit 240 kilometers an hour, the tunnel's design must avoid inclines. Tracks must remain at 500 meters above sea level, the average elevation between both hubs. But in the mountains, 500 meters above sea level translates into 2,300 meters under the peaks. That's more than 3 times the depth of the super skyscraper, the Burj Dubai. When it's complete, the 57-kilometer St. Gothard Tunnel will be the longest in the world. The tunnel boring machine makes it possible. Its 15-meter-wide rotating circular plate with titanium teeth slowly slices rock, carving a 4-story high cave. At the same time, the machine pumps grout into the cave walls for support before the actual tunnel lining is installed. Boring machines were also used to drill the 50-kilometer tunnel that includes the world's longest underwater tunnel segment at 37.9 kilometers, and the Seikan Tunnel in Japan, the world's longest tunnel overall at a whopping 53 kilometers. That's 2.5 times the entire length of Manhattan. But not all underwater tunnels are constructed by boring holes. They're made by sinking huge prefabricated blocks. In Boston's Big Dig construction project, engineers built huge airtight concrete segments in dry docks, then floated them out into the water, connected the pieces, and then flooded them to sink them into place. Finally, they were pumped dry. The longest of the 6 segments was 133 meters long, 56 meters wide, and 9 meters thick. That's bigger than a 9-meter thick soccer field. And engineers are already imagining a super underwater tunnel. Picture a 5,000-kilometer-long tube that extends under the Atlantic from New York to London, designed for ultra-fast magnetically levitated trains. Who knows? Sometime in the future, there might be a light at the end of that tunnel, too.